CI. And the second topic for today is how to create a scalable test infrastructure using Selenoid or Moon. Myself, Arun, and this is my colleague, Oleg, will be presenting how to create the test infrastructure and in the following slides. So this is the short agenda for the topic. So we will start with a problem statement. Then we will have a short intro to Kubernetes. Then Oleg will be presenting to you Selenoid with how to deploy and with a short demo. And then I will be presenting to you how to deploy Moon with a short demo as well. And then finally, the Q&A sessions. So before starting, does any of you guys maintain a test infrastructure on their premises? No? Okay, two of you guys. So any of you guys are using either Selenoid or Moon? Oh, Selenoid? Great, okay. So we will talk in detail about these things, then how we did it, okay? And so I will start with the problem statement. So as Dennis mentioned, how did we integrate end-to-end test into GitLab CI? So we have been using the services of GitLab, and we are using one Docker image, which is Selenium standalone Chrome. And when the job starts, it will spin up the Chrome browser in GitLab as a container, and that will assign a DNS with this name, Selenium Chrome standalone, which means from your job, GitLab job, you can access this Chrome browser using the Selenium Chrome standalone followed by the port number. And then you can actually run the test on the Chrome browser. Okay, so when we started with creating the end-to-end test, we had only a few number of tests, and then we had a single job in GitLab with the name test mock, which will execute all the critical paths for our application. And then when we added more and more tests into the suite, we realized that the single job is taking too much time to execute, and the developers has to wait a bit long for getting the feedback once they commit some code to the master, and it's kind of annoying for the developers. And that's when we thought about how to scale this one. So we scaled with this setup. This was already mentioned by Dennis. We grouped most of the tests into different suites, and you can see that now we have 6 suites which is running in parallel in GitLab, and each of the job is executing one suite. So now that we were able to bring down the time taken for executing the end-to-end test, and the developers were getting the feedback faster. But we kept on adding more and more UI tests as each of us do to increase the quality. And then we realized that we were ending up with the same problem that we faced before, like getting too much feedback time after the developer has committed his code. So you can see that one of the suite was taking about 7 minutes to run, which means the developer has to wait 7 minutes to make sure that his code is not breaking anything, or his code is doing the quality, having the quality that we decide. Okay, then we have one option. Either we can split these suites into sub-suites and then have many jobs in GitLab. Then we can actually have, we can change or reduce the time for execution, but that solution is not gonna scale. That's when we thought about how to create a test infrastructure and use it so that we won't come across this problem with scaling. So we have evaluated some of the open source and paid solutions, and one of them is like Browser Stack, then Source Labs, then Selenium Grid, Selenium, Selenoid, Moon, and AWS. So there are a lot of things that we investigated, and so most of them are having their own pros and cons. And finally, we shortlisted 2 of the solutions. Both are from AeroCube, that is Selenoid and Moon. So before starting off with Selenoid or Moon, I would like to get a short introduction on Kubernetes, because we are using Kubernetes to launch the browser in both Selenoid and Moon. So anyone of you guys have hands-on experience in Kubernetes? Oh, that's great. All right. Okay. So for the other guys, I will just give a short intro. So what is Kubernetes? It's an open source system for automating deployment, and it's used for scaling and management of the containerized application. So it's basically used for orchestrating the containers that is making your application. Okay, it also groups containers that make an application into logic units that is very easy for management and discovery. And these are some of the features, some of the main features which are supported by Kubernetes, service discovery and load balancing. When you deploy something into Kubernetes, it will allocate specific IP address to the ports, and it will also create a service to communicate with the port, and it will dedicate a DNS name or DNS address to the service, and you can access the port by using the DNS name. And it will automatically do the load balancing across different ports of that service. And another feature is it supports secret and configuration management, which means most of the applications or all the applications are having some secrets or configs, and you might be wondering where to maintain it, right? So Kubernetes has an inbuilt feature of maintaining the secrets and configuration, and you can deploy it into the cluster as a secret or as a config map, and then your application can directly use it. So that's one another feature, and it's self-healing. So suppose if your port or if your container crashes due to some reasons, then you might be wondering how to bring up that port again, right? I mean, so you can have many other mechanisms, but Kubernetes supports an inbuilt feature of self-healing, which means it automatically restarts the, sorry for my sound, it automatically restarts the failed containers. And even if one node goes down in Kubernetes, it will create a different node, and it will automatically schedule the ports into that nodes, and thus making sure that you are having high reliability and high availability of your application. And it also supports horizontal scaling, which means you can easily scale up or scale down your application by a simple kubectl command, or maybe by using UI, or also by automatically by checking the CPU usage. So these are some of the features of the Kubernetes, and that's why we are using Kubernetes for deploying our test infrastructure. Any questions? All right, let's pass it on to Oleg, and he will be explaining more in detail about Selenoid.
Thank you so much. Good evening, everyone. So, what is Solenoid? According to documentation, and it truly is that, this is a very powerful tool that was written in Golang that makes it really, really fast. I would say like lightning fast, because the Golang as a programming language itself compiles very fast, and it runs also pretty cool. And this is the implementation of original Selenium hub code, but I would say it manages a lot of stuff that you could manage with the Selenium server on its own. So it spins up the Docker container, and with the help of Docker API, it spins up the browsers inside of containers and communicates to them. Well, this is basically briefly what is it about. Pros of using it. It is horizontally scalable, but the scalability is manual. So if you want to increase the number of browsers or the number of hubs that you want to use, you should do it manually. You should do it inside of your configs. You should manually add Selenium hub in the config, or some kind of increase this, but manually. But it is possible. As far as I've mentioned, it is lightning fast because of it's written in Golang, and it uses like native Docker API that spins up the browser and pulls the image really quick and runs the tests also really quick. It is highly reliable because it behaves exactly like you use the Selenium server, or exactly like pretend that user would behave. Also, it's very good that it supports the video recording. The videos are stored in your Docker containers, but then they could be uploaded to the cloud service or to even your local machine. Like it's pretty simple, and it's from the box. Also, it is possible to see live execution because Selenoid has the Selenoid UI, where you can open the browser. I will show it on the demo. When you can open the browser, you can even debug over there, and it's like a browser inside of browser, and you see what is happening there, like in runtime, and you even can put debugger and behave like a user and click on different buttons in browser. Let's put it that way. And also it's open source and free. You don't need to pay anything. You just pull it from the Git repo and implement, basically. And this is how the Solenoid UI looks like. So basically, this is the logs. I will show you on demo more of that. And this is your browser inside of the browser. What are the cons of using that? As I've mentioned, it's not automatically scalable. So you need to do it manually. You need to go to the config and add as many Selenium hubs and browsers as you want. The load distribution is not uniformed in GGR load balancer. Well, GGR load balancer is the thing that decides to which Selenoid hub your request will go. But inside of the Kubernetes, it's not always managed the best way, I would say. And sometimes it can overload the Selenoid hub, and that's why it could even crash. It's not stateless. What does it mean is that Selenoid hub stores the browser ID and the session of the browser, which basically it's connected to. So if it's crashing, then the test will fail, obviously. And yeah, according to official documentation, it's not recommended to run in Kubernetes cluster, but we needed to try because we're using Kubernetes. And yeah, we tried, and Arun will come up next why we didn't decide to use it in Kubernetes. And it does not automatically pull the browser image, so you need to make a trigger to pull the latest browser image, or not the latest, but the image that you need. Well, deploying Solenoid looks very simple, and it is very simple if you are not using the Kubernetes. But in our presentation, we will show how we try to do it for the Kubernetes clusters. So if you're not using the Kubernetes, you just need to install the configuration manager. It's a virtual machine with Docker. It's pretty simple and straightforward. Then you need to use this command, and Solenoid will spin up and start. And that's it. You will need just to provide the correct Selenium URL to your config, to your tests, and it will run against the Selenoid. So to deploy the Selenoid inside of the Kubernetes cluster, you will need to install previously the preconditions. You will need to have Helm. Let's put it, it's some kind of package. It's the installer for the Kubernetes. And with this command, well, it's basically the Selenoid, and it will be in the namespace of Kubernetes cluster Selenoid in the Selenoid chart folder. So it will spin up the Selenoid inside of Kubernetes. The browser configurations, so basically they are stored, sorry for quality, in the JSON file. And yeah, I'll show more on the demo, but this is like browsers JSON with the necessary browsers that you want to use. Here is in example is Firefox, but you can use obviously Chrome and probably even Opera if you want to, but I'm not sure if you would. This is the default version that it will be taken if none of the version is specified. And here inside of the versions, you can specify a lot of versions that you need to test against. And these are the images that you are pulling from the Docker repository or the private Docker repository. Well, this is the port that will be expanded, and Selenium hub path that will be expanded to your basically end-to-end framework. Then, bit much. Yeah, and then to update the browsers, again, you should manually go back to the browser JSON and to add manually the browsers that you need to run your test against. So, and this is the interesting part. This is the architecture how Solenoid behaves in the Kubernetes cluster. So this is your end-to-end framework. This is the entry point. And the framework gives request to GGR that decides to which Solenoid go further, like pass request further. Then Solenoid, with the help of the Docker API, spins up the necessary amount of browsers that you've specified before in the config. And browser and Solenoid creates the session. Then it gives, based on this session, the browser creates the session ID, and then the session is coming back to your end-to-end framework. And basically, based on this session, the whole path goes like to both of the directions. This is how end-to-end framework and the browser speaks to each other. But taking into account the Solenoid holds the session, if Solenoid hub, for example, I don't know, GGR overloads it and it's crushed, your test will crash, unfortunately. And that's why it's stateful and it's very, very connected to this session ID. Also here we have the GGR UI that, let's put it like, it's a separate service that allows to run the Solenoid UI as a separate service. So Solenoid goes back with the data to both to GGR and GGR UI, and GGR UI goes to the Solenoid UI and makes it possible for you to see the live execution of the tests. Live demo. Just a second, I need to be the presenter. I need to stop sharing here. I need to share here. This one. Whoops. Okay. Okay, now it's fine, right? So yeah, this is basically how our repo of Selenoid looks like, and how we implemented that for the Kubernetes cluster. So this is the browser's JSON file that I've mentioned before. Again, yeah, it stores the Chrome default versions, and here it could be like a lot of versions inside of the Chrome against what you want to test. This is the quota. Okay, this is quota XML file. It is about to store the hub services that are allowing to communicate between Selenium Hub and the GGR and browser. So like it's the service, it's like a router. Let's put it that way. Also, what important is basically the Selenium Hub, how it looks like. So here are the amount of hubs that we want to spin up. This range command like goes through all of the hubs that we need are stored here in values YAML file. Yeah, so these are the hubs that we will spin up, and this is the browser limit for each hub that we will spin up. And yeah, what matters actually here? That this is the container that pulls actually the Selenoid, the latest version, and this is the arguments like the browser limit that is taken from quota file. That is the video that will be recorded, and the logs, and yeah, basically some of the arguments that you want to specify for the hub. These are the parameters that you want to give to the hub for specifying CPU and memory. Probably it could be more or less, but for our purposes it was enough. And well, yeah, basically that's it. So it's very, after that is something more specific, but overall that's it. So this is the GGR that I've talked about, this load balancer that decides to which solenoid we will route our request. Looks pretty much the same, but obviously we pull the GGR image instead of solenoid. And this is the ports that will be run inside of the Kubernetes cluster, and this is the port that will be expanded to the world, to us, to be reachable from the browser. Basically, yeah, this is the GGR UI, but it is not so interesting. It is, yeah, it's basically, this is the this is the service to communicate with the Selenoid UI, and this is the Selenoid UI as well. The YAML file for configuration. You should give very minimum amount of CPU and memory, because it's just UI information for your browser. And this will be available on this port according to like our specification. Yeah, this how it looks like in live demo. So this is the Selenium address of our cluster. It is stored here, so it is hashed. But yeah, with using of this way, it is possible to reach the Selenoid. And with this enable VNC command, enable VNC parameter property, we will be able to see what is happening in the Selenoid UI with our test. So yeah, basically we've created the very generic test. So Dennis showed you pretty much the same. And we will be waiting for 30 seconds because it will run really fast, and not to actually to see what is happening. So we are running our test. It could be like, this is the protractor, but you could use any of the frameworks, Selenium, Java, I don't know, with PyTest or something. So yeah, as you see, we are connecting to host, to our Selenoid, and this is our Selenoid UI. This is our browser, and here we go. So yeah, it was, as I've mentioned, it was lightning fast, but it actually, before it opened the Personio page, and it opened this Personio trial account. So as you can see, I even can click something here. It is, yeah. Well, it's basically browser in the browser. Sorry. Well, the test is finished and passed, and it dropped the connection and the Selenium hub as well. So briefly, this is how it works. This is how it works for us. This is how it worked for us. This is what challenges we faced, and that's why I would say we tried Moon. And about Moon, Arun will, yeah.
All right, thanks, Oleg. So I'll be presenting to you the moon from AeroCube. And so as Oleg pointed out, so if you use Selenoid, then there are many disadvantages. So one of them is it is not automatically scalable. So if you want to add more browsers, then you have to add more Selenoid hubs, which is like you have to deploy it, and then you have to update the coda.xml file in GGR, and then you have to restart Selenoid. So that's kind of a lot of process that's in between. And if there is some execution that is happening, then that can block the execution. So that's when we thought about a solution which could automatically scale. And luckily, AeroCube has come up with a solution from their own, which is a Moon that is extending Selenoid and is using Kubernetes. Sorry, just a second, guys. We are having some technical problems with this one. Yeah. So what is Moon? Moon is a browser automation solution that is compatible with Selenium WebDriver and is using Kubernetes API to launch the browsers. So since it's using Kubernetes API, we don't have to worry about how to automatically scale this, because if you have enough resources in your cluster, then it can scale. And let me tell you which are the pros of Kubernetes, Moon. It's horizontally scalable and automatic. So if your Kubernetes cluster have enough resources, if your Kubernetes cluster has enough CPU and enough memory to support maybe 100 or 500 or 1000 browsers, then you can use Moon, and Moon will automatically spins up that many number of browser, of course, if you have a license to support that many. And that is one of the advantage. And it's ultra fast, which means it's using Golang like Selenoid. And because of that, since it's compiled to machine code, it's ultra fast compared to any other programming language. And it's stateless. So another great disadvantage of Selenoid was it was stateful, which means Selenoid was storing some session information of the browser. And when your Selenoid is crashed, then it will lose all the sessions of the running browsers, and then your test will fail. But that's not the case with Moon. Moon is completely stateless, and it's not holding any information of the browser that it has started. And so even if a Moon instance is crashed, another Moon instance can pick up the execution, and then your test won't fail. And it's having uniform load distribution, obviously, because it's using Kubernetes API to bring up the browser, and Kubernetes will take care of distributing the where to spin up the browser in the right node. And we are also able to scale down the resources if not used, which means suppose when you trigger a request to start a test, then Moon will create a browser using Kubernetes API in a node. And then once the execution is complete, it will bring down the browser, which means you will be able to free up that extra resource that is utilized by the browser. And if your cluster has auto scale down mechanism, and if the cluster sees that there is not enough CPU or memory that's being used, then it could automatically shut down some of the, if it's AWS, it could automatically shut down some of the EC2 instances, thus saving you some money. It also supports video recording like Selenoid. And it's also possible to view the live execution. So you can see in the background, it's using Selenoid UI. And that's actually the same thing which Oleg's shown. So you can actually view the live execution by just logging to the, by just opening the Selenoid UI and clicking on the browser, and then that's it. So none of the solutions are perfect in the world, right? So if there are some pros, there are some cons as well. So these are some of the cons of Moon. It's not as fast as Selenoid. As I told you, this is using Kubernetes API to bring up the browser. And in the case of Selenoid, it was using Docker API, and it was spinning up the browser in the same node where Selenoid was running. Since it was using the Docker API and it was not pulling the browser image, it was really fast, and that's why we call it lightning fast. But here, in the case of Moon, it's talking to Kubernetes API, and it will schedule a port for the browser in a node, and it depends upon the capacity of the Kubernetes to when to pick up and then how to schedule it. So this is not as fast as Selenoid. And again, if some of the nodes in Kubernetes are not having the browser image, then it has to pull the image from the Docker Hub or from your private repository, and that will add up to the time. And it's a paid tool, because obviously if they're coming up with something of this scalability, then they will make it paid. And it's closed source because it's a paid tool. All right, so deploying Moon, it's really simple. So you just have to, you just need a running Kubernetes cluster, and then you are good to go. You can just get the clone the GitHub repository of AeroCube for Moon deploy, and there is a moon.yaml file, and you can just deploy the moon.yaml file into your Kubernetes cluster, and then you will have a working Moon environment in your setup. And so to communicate with Moon, you have to expose it outside, right? So you can either do it using a load balancer or an ingress service. If your Kubernetes cluster supports ingress, so better to go with ingress, or if it doesn't, you can just use load balancer, not port, and that's up to you. All right, so the browser configurations. As Oleg has shown that we were maintaining a browser.json file for Selenoid, right? I have told you one of the great advantage of Kubernetes is that there's a config map which is available where you can store the configuration, and that's the capability that Moon has used here. So they are using a config map for storing the browser configuration and their quota, and they're deploying into the Kubernetes cluster. And the browser details and the different versions or the different browsers, everything could be added into this config map. And also you can specify how much memory or how much CPU that your browser will be consuming, and also the shared memory size can also be specified in the configuration. Because if your browser does need some more shared memory, so not to crash. And this is how a simple browser a config map will look like. I mean, it's not the full path, but it's only the data part of the config map. So you can see I have mentioned the browser.json here, and there's only one browser, that is Chrome, and there's only one version, 79.0. Then you have to specify from where to pull the image from. So currently I'm pulling from the Docker Hub repo. It's Selenoid/VNC Chrome. You can also put this image to your private repository and use the URL here. That's possible. And you can give the image pull policy. So the image pull policy is if the Kubernetes node doesn't have the image, then it will pull the browser, or else if the node is already having the image, then it won't pull. That's what if not present means. Then some more options are you can either use always or never. So never means it doesn't pull the image, and always means it always pulls the image. And port is the default port where the browser will be running on. It's by default, it's 4444, and the shared memory size that you can specify here, because when Chrome is running a container, it's not allocating enough memory in the RAM, and that's why most of your sessions might be crashing, and those issues that you will see more often. And that's why you have to increase the shared memory size, and then container will be using more RAM, and then your instance won't crash. So how to update a browser? It's really simple. So you have to just update the browser. I mean, if you want to add more versions, you can add it here. Or if you want to change the existing version, you have to just update it and then just run this particular command, which will replace the config map with the updated YAML file. So the config map is stored in a YAML file called quota, and that's and here you can see that command is kubectl replace config map, which means it has to replace the config map, and the name of the config map is quota, and -f means from which YAML file it has to take the quota from, that is quota.yaml, -n is the namespace where you want to deploy the config map to. So we have deployed the Moon to the Moon namespace, and that's why we have used the namespace Moon. So this is the cluster architecture for Moon, and you can see that there are different instances like Moon API, and Moon UI. So it can have one or more instances of Moon, or one or more instances of Moon API, and one or more instances of Moon UI. So why do I mention one or more? Because you can use the inbuilt feature of Kubernetes, like, I mean, you can have replicas like 2 or 3, and if you are running maybe 1,000 or 2,000 browsers in parallel, you know that a single Moon instance cannot handle that much of load, and that could actually cause some problems, and your Moon instance can crash, and that's when you can actually scale it up by using the replicas, and you can have maybe 2 or 3 instances of Moon running, and Kubernetes will control the request, and each of the requests will be going into each of the Moon instances, and thus you don't overload Moon. And Moon is the starting point. I'm sorry. Moon is the starting point, and that's the service which is exposed outside, and your end-to-end framework will be contacting the Moon. And Moon will be talking to Kubernetes API, which will spin up a browser port and a browser service. And then you have Moon API, which is talking to Kubernetes API, and it will take all the session information of the running browsers, and it will and Moon UI will be talking to Moon API, and thus it can actually find out which all are the running browser instances, and also through Moon UI you can view the live executions as well. Any questions so far? Yeah, perfect. All right, so this is the continuation of the cluster architecture. I told you before that Moon is stateless. I will tell you why Moon is stateless. So this is the user, which is the end-to-end framework. It is requesting for a new session to Moon, and Moon will contact the Kubernetes API and Kubernetes API to create a browser port and a browser service. A browser service is used for communicating with the browser port, and Kubernetes will allocate an IP address to the browser port, and using Moon, we are giving a specific DNS name for the browser service, which is talking to that browser port. So you can see that that is starting with Chrome, then the version of the browser, then with a random UUID. And then this random UUID will be returned back to Moon. And what Moon does is it will append the browser name and the version and the session ID, which means it will effectively be the DNS name for the browser service that it has to contact to. And then it will replace the session ID, the Selenium session ID with that, and then it will just return back to the framework. And finally, in the framework, the session ID that you get is the DNS name of the browser. And if this particular version of the Moon crashes, then if the another Moon instance is taking up the request, then it knows to which browser it has to connect to, and then because it has the DNS, and then it will contact directly the browser. And that's why Moon is called stateless. Any questions? Yeah. Yeah, if you don't have enough resources, that's why, I mean, so you can actually mention how much resources and how much, how much CPU and how much memory that you require for a browser. And if your Kubernetes cluster doesn't have enough resource, then it won't spin up the browser port and it won't be available at all. Yeah, that's true. But suppose if you are maintaining the resource limit and the request limit as the same, then you can see that if some other browser service or some other services are affecting it, I don't think it will be an effect here, because we are we are always mentioning that we need suppose if we need one CPU or maybe 1.5 gig RAM, then we are mentioning that we must need this much memory and this much CPU, and this will get spinned up only when it finds that Kubernetes cluster has enough resources that is available, and that request limit will always be available to the port, which means it doesn't crash, as far as I know. Maybe if some other service is running, it could affect. I don't know much about that. So probably you are right. Yeah. All right. Any other questions? Yeah. It cannot. But it doesn't support Internet Explorer. It supports only 3 browsers, which is Chrome, Firefox, and Opera. I don't know if anyone is using Opera, but it supports. Because they have the images which only supports Chrome, Firefox, and Opera. And if you want to have Internet Explorer, then it's like you have to have a Windows environment, and then it's running on Linux, and that could probably add more complications. And and again, then I guess you have to, what I think if you are using the Moon solution, I mean, their own solution, they're supporting Internet Explorer, I guess. I mean, so they have an inbuilt cloud solution. We are not addressing it right now with Internet Explorer because we have only a few customers who are using IE, and most of our customers are using Chrome, and that's why we have, I mean, we actually targeted Chrome as a primary browser, and the next set of browser is Firefox, and so kind of IE is maybe the least used one, I would say, and that's why we don't invest much time on that. Yeah, probably if you have, I mean, I don't know, the Moon, which provides a cloud solution, maybe having that capability to use Internet Explorer, maybe, I don't know, I'm not pretty sure about that. Or you might want to use Selenium Grid, because that's one which supports Internet Explorer. But you might fall into too many issues with that because, yeah, I don't know. Any other questions? All right, then let's mobile testing. I don't think they are supporting any mobile browsers, but I mean, so they are actually supporting only the web browsers currently. For sorry, yeah, yeah, yeah. Sorry, I didn't hear.
Basically, from what I've understood, it's much better than Selenoid. It's kind of load balancers are not crashing, and it's fast. It's not so fast, but it can always do the tests
Okay,
at one point, so it's not crashing.
it's
And
not crashing.
Selenoid is crashing,
Solenoid is not crashing actually. Yeah, I mean, Selenoid is not crashing. That's not what we said. But I mean, if you are giving enough memory and enough CPU to Selenoid, then it will automatically pick it up, and then you can run your test. But currently, they are not supporting any mobile browsers, or so I cannot comment on that. Probably you may have to use maybe some paid solutions like Browser Stack or maybe Source Labs there. Oh, okay. Or maybe there could be some other solutions. I don't know. Maybe using APM, and then probably we might have to come up with our own framework, I would say, maybe test infrastructure. Any other questions before moving on to the next slide? All right, so next is a demonstration. So I have told you already, we can download the YAML file that is uh, required for deploying to the cluster. And this is that moon.yaml file. So first, what we need, we have to create a namespace. So I'm just creating a namespace with name moon dev, and I am deploying all the necessary services into the moon dev namespace. And they have some sort of role and role binding, which are there for internal things. And they're already spinning up a service for browsers, which may be for just creating a browser service for every Chrome port that is, or every browser port that is created. And then here comes the deployment plan, and the name is Moon, and it's deployed in the namespace moon dev. So this is the replica which I was talking about. If you make it 2, then you will have 2 instances of these containers which is running. And so here you can give the labels and app name for the deployment, and here I have selected as Moon. And inside the spec, you can define the different containers that you wanted to use here. So the first container that I am creating is Moon, and it's pulling the image from the public Docker Hub, aerocube/moon. And these are some of the arguments that are passed while the Moon is started. So you can give the namespace moon dev, and you obviously need a license key. So you have to specify the license file. And you can also mention the resources, limits, and requests here. So currently I have requested for a single CPU and 1 gig of RAM, and that's again my limits. And you can specify in which port it is running. So currently it's getting run in 4444, and you can also mount different volumes that are required. So here quota is for loading the browser.json file, which has the details of the different browsers and their versions. And the users is basically, so Selenoid and Moon has a capability to restrict the quota to different set of users. So if one user can have a set of browser and another user can have a different set of browsers, so that's possible. That's why they are mounting the usage directory. And also there is a license key, which is actually mounted in /license path, and they are reading it from the secret. And the next instance is Moon API, and that's downloaded from the Docker Hub repository, AeroCube Moon API with version 139. And these are the arguments. And here again, you have to specify the license key. And you can also specify the resource remits and in which port it is running. So currently this is running in 8888. And you can also specify the volume amounts, which I already talked about, like the quota, and also, the quota, which is, and again, the license key. And the last image in the deployment is Selenoid UI. So where you are downloading it from AeroCube, Selenoid UI, Docker Hub, and then you can give the status URI. Status URI is where it gets the status from. So you can see that Moon API is running on port 8888, and these two images are running in a single port, which means it can access the Moon API using localhost 8888, and it can get all the information from that. And also you can specify the WebDriver URI where the Moon is running. So you can see that Moon is also running in the same port, and you can access it using the port number and using the local host. And obviously you can specify how much resources and memory that you require. So here Selenoid UI is like simple thing. You just need maybe 0.5 CPU and a 512 megabytes of RAM. And you can also specify in which port it has to run. So usually Selenoid UI runs in port 8080. And these are the different volumes that you have to mount, like the other versions. And the next one is a service which you want to, if you want to communicate with these ports, you obviously need some service. And so this is for Moon. And if you want to communicate to Moon using 4444, this service, you have to use this service with the name Moon. And then if you want to communicate to Moon UI, which is a Selenoid UI that is hosted in port 8080, that's why you have this additional section for Moon UI. So with this service, you will be any other service which is running in a different port can access the Moon and Moon UI service. And then the next one is how to expose Moon to the outside. So currently I am using an Ingress service. So if your cluster has the Ingress controller installed, then you can use the Ingress service, or else you can just use it as a load balancer. So you just need to expose this as a load balancer, the first service. And so currently I'm using an Ingress service, and you can see that this is the host name which I use. So currently I am just hosting it my local machine, and that's why I'm using kubernetes.docker.internal, so which is the DNS name for the local host. And so currently I have just mentioned some of the routing paths here. So if it goes to /wd/hub, then it has to, in the backend, it has to route to Moon service that is running on 4444. And if you are just using a home path, then you have to route to Moon service, which is running on 8080. So I have shown you these things. So the selector is the one which is actually, if you want to talk to this service, you have to use this selector name, and then you will connect to 4444 or 8080 according to your this thing. And finally, if you are launching this kubernetes.docker.internal, you can see that it's connecting to Selenoid UI because it is routing to 8080, which is where the Selenoid UI is hosted. And then we have the config map. So currently this is a config map, quota config map, which stores the details of the browser that you require. So you can see this is the same thing which I have shown you earlier. So we have a Chrome of version 79, and it's pulling a VNC image. And so I have also in addition to the SHM size port and all the other things, I am also specifying how much memory and how much CPU that I will be needing with this. So currently I have set a limit of 1.2 CPU and 1.2 gig of RAM to the browser. So when Kubernetes schedules the ports, it will make sure that your browser will be having 1.2 CPU and 1.2 gig of RAM, and your test won't break even if the browser memory usage is below this limit. And finally, you have the secret. So you can store the license key as a secret, and then the license keys, you have to give the license key. Yeah. So any questions? So do you understand it, or? All right, so this is just a Kubernetes YAML file. You just have to kubectl apply -f moon.yaml, that will do. Then you have working Kubernetes cluster, working moon in your Kubernetes cluster. Okay, then I will go on with a short demo. All right, so this is the, so I will just get the port details. So you can see that there is only one port which is running, that is moon, and that is having 3. Can you guys see it, or I don't know how to zoom this, maybe. No, it won't work. Probably you guys can come forward because we have enough seats here. And all right. I needed to know some in this tab as well. Yeah. All right. So I have to. I cannot see it fully. Yeah. All right, so currently we have 2 services. So one is for connecting to Moon, and the browsers is a different service which I have shown you. And now I'm going to run the test. So now you can see that there is only one port and there is only one Moon service. You can just ignore the browser service for now. And so this is a simple test which 2 of the guys have already shown. You might get bored with this single test, but of course we wanted to show Personio, and that's why we are running this test again and again. All right, so we have the Personio trial account and should open the trial account creation page. And this is my config for protractor. And here you can see that, yeah. So this is a Selenium address which I have given. And this is the kubernetes.docker.internal, which will point to my local. I'm here. Yeah, I think this will. Is it fine? Yeah, so it's connecting to Kubernetes Docker internal /wd/hub, which is the hub URL for Moon. And I'm also opening the Moon UI. So this is the Moon UI, and that's hosted here in my local machine. And I'm just going to run the test. All right, it started. Let's wait if some browsers are coming up. No. That's why I told you it's not lightning fast, it's ultra fast. So Chrome browser came up and you can see the UI. And let's see the ports. You can see that there is a new service or new port which is created, and that's this one. And here you can see, yeah, this is a new service with this DNS address. And here you can see that there's a new port which is created with this Chrome 790. Then there's a random UUID. And this is the service which is used for communicating with the port. And finally, once the execution is complete, this will be gracefully shut down by Moon, and then you can free up your resources. This is not yet done, and that's why, yeah, it's still waiting for 30 seconds because we just wanted you to show, and that's done, and yeah, that's it. See, the pod is not there. The service is also not there. So any questions? So looks like everyone likes Moon or doesn't like. All right, then let's continue the presentation. I won't take much long. It's about 2 hours, you know. Selenoid versus Moon. So which one should you select? All right. So which one will you pick? Either Selenoid or Moon? So those coming with Moon, raise your hands. So only a few. Then those who are in with Selenoid. So everyone likes Selenoid, it seems, because it's open source and free. Yeah. All right. So this is some comparison which I have done. So the scalability, you can see Moon, for Moon it's automatic, and for Selenoid it's manual. And the reliability, both are reliable, of course, because we are running it in Kubernetes cluster, and you know it's reliable, kind of. And then stateless, Moon is stateless, but Selenoid is not. Then edition, Moon is paid, but Selenoid is free. Then speed, ultra fast and lightning fast. I don't know, lightning fast might be the much faster, right? So lightning fast is Selenoid is lightning fast, and Moon is kind of ultra fast. I wanted to have something like which is like more than fast, and that's why. Then maintenance, Moon doesn't require restart, but if you want to create, you know, a new browser, or if you want to scale up, then you have to requires restart. And with that, we are winding up with Q&A. So you guys have any specific questions to ask me or Oleg? Yeah.
With Selenium, I can aggregate performance metrics, for example, the first page load time, etc. Are there any specific aggregators for this when I scale up? Well,
If you want to have a performance matrix, I think that's an implementation, like, I mean, capability of the Selenium, right? I mean, so all the things which are supported by the Selenium WebDriver is supported by the Selenoid as well, because it's a capability. So that means it should be supported. Yeah. Any other questions? Everyone are tired? All right. So that's with Selenoid and Moon. So you can now decide which to select. And now I will hand it over to Dennis.
Yeah, thanks everyone. Thanks guys for cool presentation and with a comparison. Now you know our journey, our challenges that we had. So it's not just only GitLab with its own browsers that spin ups, and you cannot actually allocate resources, CPUs and memory, right? But you can do some cool stuff by using and scaling it with Moon or Selenoid. It's up to you to choose, or just at least consider. Again, thank you everyone for joining, and thank you for choosing us this evening instead of anything else. And we would be grateful to see you again, and let's have some networking session afterwards. Yeah, thanks.